Class, welcome to another lecture on number conversions and the number system. So this time we will be converting decimal into octal. So guys, you must be remembering how to convert decimal to binary. So in that particular case, let's say we are converting 9. So 2 4s are 8, the remainder is 1. 2 2s are 4, the remainder is 0. 2 1s are 2, the remainder is 0. 2 zeros are 1, and the remainder is 1, right? So now you read it this way. So this becomes 1001 with a base of 2. So 9 in the base of 10 is basically 1000 to the base of 2. Now when you do decimal to octal, right? What was the base of binary? So you basically divided by the base. The base was 2. So now when you do this in octal form, what is the base of octal? The base of octal is 8. Octagon. Oct is 8. Right? So now let us take the example for 214. So we want to convert 214 of decimal into something of octal. Since something of octal is there, you need to basically convert of this. So what you do now, you divide by 8, right? Why? Because the base of octal is 8. Similarly, when you do decimal to hexadecimal, you will divide by 16. So now let us take, when you divide 21 by 8, so 8 to the 16, 54, and 8 6 are 48, right? So what remains? I think the remainder is 6 in this case. Fine. 2s are for 54 and 6. Yeah. Then again 8 3s are 24. The remainder is 2. 8, you cannot divide 3 by 8. So 8 zeros are 0 and the remainder is 3. Right. And again you read from bottom to up. So 214 if decimal is equal to 326 in octal. Right? Obviously this also makes sense because octal has only 8 digits, right? So basically it will have a higher value than the decimal. Fine. So this is how you convert decimal to octal, right? Similarly, when you basically do decimal to, let's say, just I will give you a brief. So let's say you are doing decimal to hex. So in that particular case, what is the base of hex? Hex, the base is 16. So let's say you divide 30. 30 into 30 of decimal is equal to question mark of hex. So since it is hexadecimal, you divide by 16. So 16 ones are 16, the remainder is 14. 16 zeros are 0, the remainder is 1. Now look at the master table. So when you look at the master table, what is 14 of binary into hexadecimal, right? So 14 of binary into hexadecimal is E, right? So this 14 you need to further write as E because in hexadecimal 14 represents E. 1 remains as it is. You again read from bottom to top. So 30 of decimal is basically 1E of hexadecimal. So this is decimal actually 10, right? So this is how the conversions actually take place. So when decimal to binary, you divide by 2. When decimal to octal, you divide by 8. When decimal to hexadecimal, you divide by 16. So in this manner, you can basically convert to any of the base. So for example, let's say I define a new number system which has a base of 5, right? So let's say I want to convert a number, let's say 18, into something of base 5. So now let me just change the pen color. Right, so 18 into something of base 5. So just important thing is, what is the base? So base is 5. So you take 18, divide by 5. 5 3s are 15, the remainder is 3. 5 zeros are 0, the remainder is 3. Read from bottom to top. So 18 of 10 basically is equal to 33 in the base 5. Right, so this is a general technique to basically convert decimal into any format with the given base. So guys, thank you for watching the video.